We start the week off with a simple video on information sets. So far, we have only considered extensive form games with perfect information. At each decision node, each player knows what the other one has played so far if the game has come to this particular decision node. So this means, for example, that when player 2 has to decide whether to play defend or retreat, player 2 knows this decision follows player 1's decision to play fight instead of flee. Likewise, when player 2 decides between stay and follow, player 2 knows this happens after player 1 plays flee. In a game with imperfect information, the players sometimes do not know what the other one has decided. So for example, imagine that in the game on the right, player 2 is not informed about whether player 1 has played north or south. So when deciding whether to play east or west, player 2 does not know whether she is in the subgame on the left or in the subgame on the right. Obviously, this only makes sense if the branches are identical in both subgames. To show that a player does not have perfect information, we introduce information sets. An information set includes all nodes where a player has the same information. As the game on the right is written right now, player 2's first decision node and player 2's second decision node are different information sets. At the first decision node, player 2 knows that player 1 has played north, and at the second decision node, player 2 knows that player 1 has played south. So each node is their own information set. If player 2 makes the decision between east and west not knowing whether player 1 has played north or south, then the two nodes are in the same information set. We denote an information set with either a dashed line, an oval shape, or a rectangle. It does not matter which one you use. I personally prefer the dashed line. So we've already said this, but it is worth repeating. If the branches of two decision nodes are different, so not the outcome but the moves, then they cannot be in the same information set. The example on the right is wrong because defend and retreat can only follow fight, and stay and follow can only follow flee, so player 2 always knows at which node the decision is being made. Let's look at some examples. In this case, both of player 2's decision nodes are an information set, so that means that player 2 does not know whether player 1 has played A or B. In this example, all 4 decision nodes of player 3 are in the same information set, so that means that player 3 does not know whether player 1 has played A or B, and player 3 also does not know whether player 2 has played L or R. In this example, however, player 3 knows whether player 1 has played A or B, but player 3 does not know whether player 2 has played L or R. In earlier videos, we said that a strategy must contain a decision for every decision node, but that is only correct under perfect information. Under imperfect information, a strategy must contain one decision for every information set. In this game on the right with perfect information, player 2 has 4 strategies: east-east, east-west, west-east, and west-west. In this game, where the two decision nodes are in the same information set, player 2 has only 2 strategies, east or west, because player 2 does not know whether player 1 has played north or south. A quick test: what are the players' available strategies in this game? Player 1 has the strategies A and B, player 2 has the strategies L and R because player 2 has only one information set, and player 3 has the strategies TT, TG, GT, and GG, one move for each of the 2 information sets. So as you can see, a strategy always contains one move per information set. Now here we have a normal form game and an extensive form game with imperfect information. In the normal form game, player 1's strategies are north and south, and player 2's strategies are east and west. And likewise in the extensive form game, the payoffs are also identical. So is there any difference between the two games? The answer is not really. These are in fact 2 different ways to represent the same game. Even though on the right we have an extensive form game, and player 1 technically makes a decision earlier, since player 2 does not know what player 1 decides, it is effectively the same as if they both make their decisions at the same time. Importantly, this means that we can now represent simultaneous games with more than one round in 2 players by using extensive form games with information sets.